The next step is to create the fluid structure interaction. So we want to see the effect of the CFD result on the pipe structure so that we can get the stress contours as well as the velocity contours for the fluid. So the first thing we have to do is copy the CFD model and create a new version which we'll call something like int CFD for interaction. The first thing we need to do is, when we're in our new int CFD model here, we go back to the boundary conditions, we go to boundary condition manager, and we want to suppress the wall boundary condition. The reason we want to do this is because we're now looking at the interaction between the surface of the fluid and the inner surface of the pipe. So we need to define that boundary condition as an interaction instead. So this boundary condition can be disabled. While we're still in the boundary condition manager, we need to add a couple of mechanical conditions here. So we'll go to create. In the CFD step, we'll call this condition pin condition. We'll select mechanical. We won't select from a fluid region, we'll select the outlet faces and the inlet face. And we will constrain the motion in all three directions. In order to create our fluid interaction surface, we go to interactions and we'll name the surface, let's name it interaction, continue, and we'll select the surfaces. So we want the surface of the fluid to interact with the surface of the pipe, so we'll select all of these surfaces here and accept that, and OK, and our surface interaction is defined. We're now going to go back to the pipe geometry for the pipe section. So we're going to create a new model by right-clicking Models, Create, and this is going to be a standard and explicit model, and we'll call this something similar, so we'll call it int underscore pipe, and we'll click OK. And now we're going to import the hollow pipe part into this model. So we'll do model, copy objects, and we're copying from our original model CFD into our interaction pipe, and all we need is the pipe part. Click apply, cancel. We'll go into int pipe, and we have our original pipe part. We'll assign a material to the pipe, so we double click material and we'll just call it something like metal. We'll give it a density of, say, 2000 kilograms per meter cubed, and we'll give it some elastic properties. We could give it say 80 gigapascals and a Poisson's ratio of 0.33. We'll create a section which we'll just call pipe, and we'll assign the material metal, and then in the parts container we'll create a section assignment, select the whole part and choose pipe. We'll create an instance of the pipe by going to assembly and double clicking on instances. We'll choose pipe and click apply and cancel. The pipe should already have a mesh associated with it. If we choose make independent and click on mesh and then control space, we can see that we have the original mesh that we created at the beginning of the tutorial. We'll now create a step for the pipe analysis, so we'll double click on steps, and this time we're going to choose a dynamic implicit step. Click continue, Now this part is important because in order for the co-simulation to work properly, the step definition for the pipe and for the fluid has to be identical. So if you remember from earlier, the time period we chose was a fifth of a second. For this setting here, controlling the inclusion of nonlinear effects, we'll turn that on. In incrementation, we'll choose the same increment as before of 0.001, and we'll increase the maximum number of increments to 500, and we'll choose to suppress calculation, and then we'll click OK. Next we'll create a boundary condition at the inlet and the outlet. So again, we go to boundary conditions, we'll create an inlet boundary condition, and we'll choose this face. We'll choose to restrict motion in all three directions, and then we'll create another boundary condition which we'll call outlet, and we'll choose the outlet faces. And once more we'll restrict motion in all three directions. Now we need to create the interaction between the pipe inner surface and the fluid outer surface. So we'll go to interactions, and we're going to choose fluid structure co-simulation boundary. And this is the important part, we have to give it the exact same name. So we'll call it interaction. And now we have to choose the inner surfaces of the pipe. So we'll do that like so. And in order to check that we've got all the surfaces, we can change the view type, change to wireframe, and we can see that we've captured the entire inner surface of the pipe. So we say OK, confirm the name as interaction, press OK, and now our fluid structure interaction is fully defined. Finally, we can create the job. Before we create the job, what I discovered earlier is that the job can't be submitted with the old mesh. So if we go back to the mesh, what you have to do is delete the mesh using delete instance native mesh, and then just remesh the part and redefine your boundary conditions and interactions, and you should be good to go. So if we go down to the analysis section, we can see the old CFD job where we only looked at the CFD problem. If we go to co-executions, we can choose int CFD and int pipe and click OK. Then to start the job, just go to co-execution 1 and then right click submit. Once the analysis has completed, we can right click on co-execution 1 and results. We have two output databases, one for the pipe and one for the CFD. So if we first look at the CFD result, we can select feature edges only, and we can view the standard contours such as pressure, displacement and velocity. And once again we can go to the resultant velocity in terms of our vectors. So this is the CFD result. If we now want to look at the interaction between the CFD result and the pipe, we can switch to the pipe ODB, and if we view contours on deformed shape, we now have the stress on the pipe due to the fluid flow. We can go back to view all edges. If we select cut view in the x direction, we can analyse the stresses on the pipe in the x direction, and we can do the same in the other two directions. If you wish to compare the CFD result to the pipe result, we can go to Viewport, Create, and then Viewport, Tile Vertically, and we now have two viewports. And if we select the first viewport, we can choose the CFD ODB, and for the right hand viewport, the pipe ODB. You can use this Fit to View button to get a better view. If we go to Feature Edges, we can now view the velocity vectors. So there we go. On the left hand side the CFD simulation, and on the right hand side the stress on the pipe due to the flow. That concludes the tutorial on using co-simulation for CFD problems in Abaqus. I hope it's been helpful. Thanks for listening, and see you again soon.